Good afternoon, everyone. Today should be a relatively short video about some other versions of the transform translate method. So I'm going to talk a little bit about how we can use the coordinate system, the local and global coordinate systems to our advantage, and we're also going to discuss a new type of variable called a vector3 object. We're going to get to that in a bit. But first, I want to take a look at the translate method that we already have. I hope there's not too much of an echo in here. I'm recording this on a laptop, so again, I don't have my headset, so the audio quality may not be super fantastic, but hopefully it's not too horrible to listen to. So this is the version of the translate method that we know so far. We call transform.translate, and we pass it an x, a y, and a z value. And this method can either be beneficial or troublesome depending on how we want our object to behave. So I've already created a script here and I've attached it to my cube in my scene. Let's take a look at what that script looks like so far. What this script does right now is it gets the value of the horizontal axis, and if the horizontal axis is moving in a positive direction, then the cube rotates in a positive direction. If it's moving in a negative direction, the cube rotates in a negative direction. So let's take a look at that. So if I press play, if I press D, it's going to move one way, rotate one way, and if I press A, it's going to rotate another way. So that seems to work just fine. But let's talk about what happens when we actually start translating our cube. So I'm going to add a little bit of code here to translate our cube forward and back. I'm basically going to copy the code that I used here, but instead of checking the horizontal axis, I'm going to check the vertical axis, and I'm also going to call transform.translate instead of rotate. And instead of moving along the y-axis, I want to move along the z-axis. So every time I press forward or back, I'm going to move my cube is either going to move forward or backward. Let's take a look at how the rotation affects this. So notice that the only value I'm changing is the z value of the cube. I'm only ever modifying z. So if we select our cube, and then we hit play, keep an eye on the rotation values. I'm going to turn my cube towards the camera. So right now I have a y rotation value of 94, and now let's watch the z value. If I move my z value, it looks like the cube is moving left and right. And notice that the z value increases or decreases, but I'm also noticing a change in my x value. Why is that? Well, if I rotate my cube this way and now try to move, I can see that the cube moves along a different axis. By default, the transform object translates objects along their relative axis. So if this side of the cube, if this direction is my z-axis, when I rotate the cube, I'm changing the relative z-axis. So now the z-axis is moving towards me as opposed to moving to the left and right. So the transform method, as we know it, deals with relative axes. In other words, the relative x, y, and z of this cube. But we have an overloaded version of this method that takes an x, a y, a z, and a space. Space is a special type of object or class that talks about the relative unit or the relative space of the translation. By default, if space is not entered, then it goes by the relative space of the cube, but we want to use the global space. So let's actually try passing it in. So now if I say transform.translate, and I'm going to actually bump this up a little bit so it moves a little bit faster. If I say transform.translate 0.05 f and I add a space relative to, I can do that by specifying space dot world. Space.self is what it's set to by default. Let's take a look at that. Let's take a look at that again. One of my options is space.self. That's what it normally applies itself to, but I'm going to use space.world. Now if I hop back into my Unity editor, I'm going to stop that, run it again. Now I'm going to press A and D. I'm going to press W and S to make it move. And now notice that it applies itself to the global. Let's watch our Z values. Watch our Z values over here. Now only our Z value is changing because it's applying to the global axis. No matter which way I rotate this cube, the cube can keep rotating, but as long as I press forward and backward, it'll only move forward and backward because I'm using the global space as opposed to this cube's space. So those are really handy. There's one other, and I'm just going to put the options in here. We can either have space.self or space.world. There's one other option that uses something called a Vector3. So a Vector3 object is basically an object representation of 3D coordinates. So there's a version of transform.translate that takes a Vector3 and a space, and there's also a version that takes a Vector3 and no space. And just to give you an idea of how this is different, it doesn't make that big of a difference in the translate method, but we're going to be using Vector2s and Vector3s a lot when we get later on in the class. So we have to make sure we understand how they work and that they exist. So I'm going to create a couple of vectors. The first one, I'm going to say Vector3 forward equals new Vector3. And I'm going to pass my Vector3 three floating point or float numbers. And I'm going to use this to represent the forward direction of my world. So I'm going to say 0, 0, 0.05f. Like that. I'm just going to make sure we didn't break anything. Good. So now I've created a variable called forward that represents how much I want to translate on the z-axis by. So this is saying a vector, think of a vector as being a particular force in a particular direction. So a Vector3 says I want 0.05 force in the z direction. And that's going to allow me to move forward. If I wanted to move forward diagonally, then I might say Vector3 0.05f on the x and 0.05f on the y. And this is going to move me both in the x and y direction, so I end up with something like that. So they're a little bit more reusable. It's kind of the same reason why we use variables to begin with, right? We declare this vector once, and then we can just use forward anywhere where we want to use it. I'm going to create another vector called Vector3 backward, and set it equal to a new Vector3, 0, 0, and negative 0.05f. And then all I have to do down here is replace these three parameters with one parameter. I can say transform.translate forward and transform.translate backward. Not only does this eliminate some extra parameters that we don't need, but it allows me to be more descriptive, right? I know the purpose of this translation is to send the object forward. The purpose of this translation is to send the object backward. So let's take a look at that. Just to show that nothing has changed, we can see that we still move forward and backward regardless of which way we are rotating. Last thing I want to show you guys, there are some Vector3 presets or constants that are kind of useful. So if we wanted to, we could use Vector3 dot back, which is, as you can see right here, 0, 0, negative 1. We could use vector3 dot down, which is 0, negative 1, 0. There's a whole bunch of them that basically apply one unit in a given direction. Down, up, back, left, etc. So we can always use those as well if we don't want to create our own custom vector. The last thing that I want to show you guys with vectors is that vectors can be multiplied. So I can multiply a vector 3 by a number and it'll apply to every coordinate in that number. For example, if I wanted this to go twice as fast, I could say forward, let's do it this way. Vector 3 faster equals forward times forward times 2. Let's do that. And then instead of using forward, I'm going to use faster. So now I move towards myself the same speed, but I move away from myself faster because I've multiplied my vector by 2. Another way that this could be useful to us is it means that I don't need, get rid of this, I don't need the backward variable anymore. So instead of setting backward equal to a separate vector and introducing another opportunity, I could say vector 3 backward equals, and what would we multiply forward by to go in the opposite direction? Well, we would say forward times negative 1. And what that's going to do is that's going to multiply that negative 1 across each of these values. So for 0 and 0, these guys will stay 0, but 0.05f will become negative 0.05f. So let's make sure our code still works. And we can see we can still move in both directions. So this was a pretty quick video, as I said. I hope that you guys find some interesting use for the space option in our translate method, and also get comfortable with vector 3s. Vector 2s look very similar, except they only take 2 coordinates. We're going to be using vector 3s and vector 2s a lot as we move on in this course for things like collision detection, for being able to move stuff certain amounts. There's going to be a lot of uses for these guys moving forward. Thanks for watching.